Well, hi, welcome back, everybody. This is homework 4.2, and we just finished up question number 5. Actually, 1, 2, 3, 4, and 5, but 5 was the first problem that we had to work on. So we're going to continue with number 6 right here, and I'm going to make that go away and have 6, 7, and 8 show up right here, and I'm going to write over here on the right-hand side now for a change. So we have question number 6, and we've got what should be hopefully a familiar looking molecule to you. We call this water, of course, H2O, and we have hydrogen atoms here that are at a certain degree angle from each other. We're used to seeing the H2O molecule looking like almost like you might call it a Mickey Mouse head, with the central oxygen atom and then the two hydrogen atoms not in a straight line with each other, but they're actually at an angle of 104.5. So what we're trying to find here is what's this distance between this hydrogen atom and that hydrogen atom right there. What is that distance? Well, you might think we could just start taking some sine functions, because after all, we do have a triangle right here. But the problem with this triangle is that it's not square. You can see that this right here is not a square triangle, even though I drew that in there. But that angle is 104.5 degrees, not 90 degrees. So we need to do something about this. What I'm going to do is I'm going to transfer this over to the to the left here. So this will be number 6. And here's our non-90 degree or non-right triangle. So this is 104.5 degrees from there to there. So that's not a right triangle. And what we want to find is this distance from this point to this point. Now we are given one other bit of information, and that is what one of the legs of this triangle is. Even though it's not a right triangle, we still do have some legs. And that is, well, both of the legs are 0.96 A with a circle over it. What is that? You ever seen that before? Again, I think I mentioned it in class, but that's called an angstrom. That's 1/10 billionth of a meter. So it's pretty darn small. We use it to measure atoms, and that's just the unit we're going to be using. So that right there gives us some point of reference, or that it gives us some dimension of this. But we still need to be able to find what this distance here between the two hydrogen atoms is. Well, we can't use this triangle here that we're given because it's not a right triangle. But what if we took this triangle and we just bisected it, or just cut it right down the middle like that? Now all of a sudden we do have a perpendicular intersection there. We do have a right triangle, but it's just half of the original size. Well, I'm going to take that now and I'm going to transfer that over to here. Make it a little bit bigger so we can see it. Something kind of like that. Let's try that again. Make that a little straighter there. Oh, whatever. No, I want to make this look right. What did I just let me just do here. There we go. Try this one more time. Let's go. Like that and like that. Hopefully that represents this triangle right here. All right, sorry about that. And we have our right angle right there, and we know that this side is 90 or 0.96 angstroms from there to there. And well, so what about these angles right here? Well, if we took this 104.5 degree angle and we simply cut it in half, or we bisected it, so from here to here, that should be half of 104.5. So this angle right there should be 52.25 degrees. And for anybody who didn't hear me say it in class, it may be interesting to note that 52.25 is a palindrome. That's something spelled the same way frontwards and backwards. But of course, I'm sure you already knew that. So 52.25 degrees is what we have it in this corner. That is from the horizontal part of this triangle down to the hypotenuse. So this is 52. Oops, let's change that. There we go. That's 52.25 degrees right there. Well, now we can actually work with this triangle and start solving part of it. Again, let's not forget that this is the side right here that we want to solve for. And if we can solve for this side, all we need to do is double it, and we'll have the whole distance between the two hydrogen atoms. But let's see what we have. What kind of things we need to solve for. Well, this right here, I'm actually going to call D. I'm going to give it a name because we need to be able to solve for it. So this side we want to solve for. We know this angle and we know this hypotenuse right here. So with respect to this angle, this side D is opposite. So D equals the opposite. And you could call it whatever you want, D, H, F, X, whatever. But I'm just calling it D. So that's the opposite side. And of course, with respect to this angle right here, 0.96 is 0.96 angstroms, oops, not degrees, angstroms equals our hypotenuse, HYP. And, oops, didn't want to bring that up. Sorry about that. Change the colors here. What other thing did I miss? I missed our angle, right? Our angle theta is 52.25 degrees. So the question is, what sine function do we use? What sine function do we now use? Well, let's look and see what sides we have. We have the opposite, and we have a hypotenuse. And so which of our SOHCAHTOA sine functions involves the opposite of that in the hypotenuse? Well, that would be the sine. SOH means the sine of an angle equals opposite over the hypotenuse. So we should be able to solve for this opposite side right here. So the sine of what angle? 52.25 equals the opposite, which is D, over the hypotenuse, which is 0.96 angstroms. Well, we want to get D by itself, so we're going to multiply both sides by 0.96 and bring it up next to the sine 52.25. So 0.96 sine 52.25. And really what we're doing is we're multiplying. So that's that x in there. But I think on most calculators, if you simply put a value out in front of a sign, it automatically assumes that you mean multiply by this. So if you just typed in 0.96 sine 52.25, and again, your calculator wants to be, you want that to be in degree mode, 0.96 times sine 52.25 should give you our answer D, which is 0.75 angstroms. So if this right here is 0.75 angstroms from there to there, then that means double that. My phone is ringing and I'm not going to get it. In fact, I'm going to hang up. And it's a solicitor, of course. Yeah, I'm not getting that. That is, we want to double that. So times 2 angstroms times 2 equals, of course, our answer is 1.5 angstroms. That's going to be our distance from one hydrogen atom to the other. 1.5 angstroms. Okay, let's go on to number 7.